Hey everybody, we're going to do our notes on constant velocity. So think about your car. How do you make your car go the same speed all the time? Cruise control, right? Otherwise you're changing your speed all the time, going around corners, accelerating, decelerating. So right now we're going to talk about being in cruise control and how that can be calculated. So these were in our original list of vectors and scalars. Speed is the rate of change of distance. Velocity is the rate of change of displacement, and it's a vector. So this requires us to look at direction. This one does not. So this is my little disclaimer for the next couple of units, is that we're not going to be looking at distances that go out into space, and we're certainly not going to do big distances that go around the curvature of the Earth. So relatively small. And in some cases, we're going to be using these speed and velocities very much interchangeably. So there's still, again, the change in distance or displacement over a period of time. So if you haven't already seen the Greek letter delta, delta means a change in and officially a subtraction. Eventually we'll get a little careless and leave out the delta and simply write it as v equals d over t, knowing that v is velocity and v is also going to stand for speed. And this is, you had this problem in middle school. Distance equals rate times time. That's the same formula. The rate is the same thing as a velocity, so it's just cross multiplying. So this is not really a new formula, but I do have to look at these. So let's take a look at this problem. A car travels 50 kilometers in 2 hours. What's its average speed? So I'm going to ask you to start writing down variables. D. Well, that's the distance. It's 50 kilometers. The time is 2 hours. What formula are we using? Well, obviously this one. V average is distance over time. See, I already dropped the deltas. Okay, so it's going to be 50 over 2, or 25 kilometers per hour. Let's go to the next page. So let's look at a second example. So now I have a vehicle. It's going to go 80 kilometers west. Notice I added some directions, and it takes 1 hour, and then turns around and goes 70 kilometers in 2 hours. So if we're going to do speed, that's distance over time. Well, the distance, I don't care about direction, so I have 80 plus 70. So 80 plus 70, and the time is 2 hours. So if I just work this out, 150 over 2, we're going to have, 350 kilometers per hour. Okay, that's an average, the way you would figure out your speed going in a car anyway. Displacement, though, we have to think about the fact that we had 80 west and 70 east. These are vectors. Remember, west is going to be negative. That means that our total is really 10 west. So I'm going to do my displacement over time. My velocity is going to be 10 over 3, which equals 3.33 kilometers per hour. And I have to include the direction of west. Not a very hopeful kind of velocity for judging going to a place. We definitely try to use speed more. So here's a question. How can I have 0 average velocity and still an average speed of 100 kilometers per hour? So think about it for a second. I can speed at 100 kilometers per hour, which is about 63 miles per hour. But how can I have 0 velocity? So that only works if we go back to the start. You can speed all day, but if you technically go back where the two distances cancel, you'll have a 0 average velocity. So let's talk about graphs. Okay, if this is a time axis, this is a distance or displacement, and this is velocity. Uniform motion means we stay steady. So I will have a straight angle line. If I have a steeper line, it's going to be faster. Maybe I'll cruise controlling at 80. If I have a straight line here, slower. Whatever the slope is, remember distance over time is going to give me the velocity, and the velocity stays the same because the slope stays the same. So on here, we'll call this medium speed. Medium speed might be here. Slow just means it's lower, and fast just means it's higher. After we're done with the notes, we're going to be taking a look at some graphs and asking some information about them. So kind of quick and easy notes today, and we'll follow up when everybody's ready. Thanks, guys.